With a compass, there are two elements to the compass that you're going to concern yourself with. It's like any normal compass. We can work out a direction, compass direction, but internally within it, you've got this needle, and we'll talk about how we work with it in a minute. We've got this needle here, which is called a clinometer, which obviously gives us the inclination of a line or a surface. So let's go back to our bedding. Okay, we're going to measure the orientation of the bedding from a field point of view. There are three, like I said to you before, three elements to that: strike, dip, and dip direction. Okay, there are different conventions. You kind of just measure the dip direction, but out of habit, I always go with strike, dip, and dip direction because it gives you an immediate feel for the direction of dip. So let's take this. We've determined that this is a bedding surface. This is a kind of a smaller, thinly bedded sandstone, quite variable. It actually looks like it's been pinched a little bit, so there's a little bit of what we call boudinage here, but we won't worry about that. So the first thing we look at that, we define a horizontal line on the surface, which is our strike line. Okay. One of the best ways to do that actually is to start by finding the orientation of the dip, which is the line of maximum inclination. Okay, and we can use the clinometer to do that by aligning it east-west with these 2 points here. That needle, that with the diamond head on it, then can swing freely. We need to make sure that we don't tilt it off the vertical plane. It has to be kept in the vertical plane, perpendicular to the surface. So there's our surface, and what we can do is to find the strike, or the line of dip. We can just tap it, keep moving it till we get a maximum inclination, which is about there. It's easy when you've got steeply dipping beds like this. It's very easy to do that. Lift it, and we can read off the dip value there. It's about, just looking at it, it's about 70. That gives us a reading of 70 degrees, which is there's your line of dip. The line of strike is always on the surface 90 degrees to the line of dip, and that has a zero dip. It's a horizontal line on it. Okay. Now we measure the compass orientation of that line. Okay. So again, let's just stand up here. You get a bit more light. We take the compass. Now we're holding the compass flat as a compass. We put it along the long axis of the compass along the line of strike, making sure that it's not off the
Is the spirit level built within the compass?
There is a spirit level, not in this one, and to be honest, there isn't the need for that level of accuracy for that. As long as you're holding it sub-horizontal, it will be fine. You orientate the needle and the black arrow on the face of the compass, like so, so you're orientating the compass. So immediately that is north, south, east and west. And we lift it, and we can read off the precise alignment of the strike line. In this case, if we look at it here, it's about 078. Okay. Now you can read off this side as well, which is faded in this compass. I always go for the lower value. Okay. So if we imagine that that's north, that's striking off 078 in that direction, and in this case it's striking off at about 260 off in that direction. If we come back to it, it's 078, 60, because that was our dip value, and then we just need to determine, is it dipping 60 in that direction or 60 in that direction. So very, very quickly we'll just take the compass, align it, that's south, that's north. These beds are clearly dipping to the south, so we'll stick in south. You can clearly see, hopefully, that the bedding is like that, dipping off to the south, and we'll take a measurement in the reading. But in addition, we have another fabric coming down at a very high angle like this. You see that?
Yes. Cleavage.
That's a tectonic fabric. That's your cleavage fabric. Yeah. Okay? So it's when you have a case where the bedding is very, very steeply dipping, this cleavage fabric is usually at quite a high angle in this part of the basin. So we've got bedding, we've got cleavage. As far as, I suppose, from the morphology of the outcrop surface, these are the two primary controls in determining that. I would argue here bedding, and it's good to see that bedding has the most obvious expression. Obviously, and if you can just come slowly around this side, we can see that there are a number of clean fractures coming through, cutting across. This is the surface of a fracture. There's one here, my hand, I'm pointing them out. You see them? Mm-hmm. These are joint fractures that cross-cut the bedding and cleavage. Okay? They probably also will have an important bearing on characterizing the morphology of the outcrop surface. So if we take this as a cleavage surface, we can very, very quickly take a reading. And I'll just do that for completeness sake. So it's striking 084. It's dipping 90. It's vertical. You don't have to give a dip direction when it's vertical because it's straight down. Going out, it's almost. The dip has decreased, but the strike, and this is the important thing, the strike has swung around almost now to north-south. Yeah? So you can see, if we were to take a strike reading of the bedding there, so what we're seeing is this closure. And we've got into an area here which is more complicated.
Some mini folds there.
Some minor folds, absolutely. But overall, we're looking at this trough-like structure, which obviously we call in geology, assuming the beds are the right way up, and they are here, we call this a syncline. Okay? So we have a three-dimensional view of a plunging syncline. It's very obvious looking at the geometry here that it's plunging. If we were to take the axis of this fold, which is the line of maximum curvature on the fold surface, it's plunging off to the west. Okay, now that's important. Okay, and one of the ways we had a very crude approximation, going back to the structure earlier, is that where the bedding and the cleavage intersect, that bedding cleavage intersection line or lineation, that's a very good, in cases like simple folding cases like this, that's a very good approximation for the fold axis orientation. You can see the lines there on the surface of the bedding, and they're clearly parallel to the direction of the fold axis. Now I'm drawing it as a complete structure, yeah? The minor folds, that let's say there are minor folds on the limb, quite often have this geometry. And if you look at them, if we go across the other limb, we get that. Yeah? In the hinge area, typically you get this. Now there's an important geometrical story here. These minor folds in the hinge are symmetrical. The length of the limb is the same for each fold. These folds down here in the limb are asymmetrical. You get one long, one short, one long, one short. Okay? That's the first thing. Normally in minor folds you see symmetrical minor folds in the hinge of these big structures. You see asymmetrical folds on the limbs. In addition, as we look at this geometry, we can imagine there's a symmetrical fold. And as you're looking at it in profile, you imagine what sense of rotation would give you this kind of asymmetry, okay? Now imagine I'm tracing it around like that, and then it's going back out like that again, okay? It's a continuous surface. I can only do part of it with my hands here. So there's a sense of rotation. So the rotation, for instance, in this one is towards that direction. And the rotation for this fold is like that.
Towards the center.
Towards the center, towards the hinge axis. For anti-forms, which are these closing upward folds here, the minor folds, that sense of rotation which we call vergence, always verges towards the antiformal cores. So you can see all these beds are all gently folded, you know, very subtle folds. What way are they plunging, would you say? If that's out to the west.
West, yeah. So they're plunging west.
They're plunging west. What are the different things you can see then when you look at in more detail?
You see the bedding planes.
Yeah. So the
then you see
planes are clearly, these are the layers that are being folded. Anything else?
Yeah. Then you see the cleavage, vertical lines.
Perfect. Now you particularly see it in the more competent units. That very shady stuff is not that difficult to see it because quite often they have a compaction fabric in there as well, which kind of obscures it. But if we look what I'm standing on, you can see this is the bedding surface, and then you can see it's coming through. You've got this cleavage. This is your bedding cleavage line here. If we turn around and we look off in towards the cliff, we can see there are these big, again, roughly north-south orientated fractures. So you're starting to see there's a consistency.
Fractures going in this direction.
This direction, roughly north-south. And you can see there's a consistency in the overall direction of these main elements. So you see what I'm saying? Even though we've crossed the headland, the same elements are here. So this is clearly, can you point out the cleavage fabric first of all? Absolutely. It's that high angle fabric. Now you're measuring the cleavage as, are you measuring the cleavage? Can you just with your hand show me the orientation of the cleavage? Yeah, so it's a plane, it's like a sub-vertical plane, okay? So you need to find this, you need to find an area where you're seeing its side, in profile. You're looking at it, so this, if you're going to measure the cleavage, okay, hang on. If you're going to measure the cleavage, you're going to have to look for a surface like this, here.
But for the strike,
the strike is, always use it in this surface, even though what you're doing is technically you need to see the actual surface to measure the strike properly. Now what you're doing is correct. Okay.
And it's going to be 80 degrees.
080.
080.
Okay, and keep going then to get the dip and dip direction.
And the dip would be, let's say 90 degrees.
Okay, it's almost vertical. Perfect.
It's 87.
Yeah. So again, and the reason I'm bringing you here is an important lesson from the point of view of extrapolation. This whole area here, Max, we're in the core of the syncline, the same syncline that we were looking at across at the other side of the head. Okay? So you can see there's lots of minor folding, quite spectacular. And some of that looks quite symmetrical in that you can see, okay, there's that part of it is symmetrical, then it comes down to this longer limb here. So we've got this zone here, and as we walk back along over to where we've just come from, the folds are all doing that low. If you were to put a surface over all the folds, it would be a very low dipping surface. We call that an enveloping surface. It's a surface over the whole folds. So generally speaking, the bedding is like this here, with folding within it, yeah? But as we move over to the south, beds become very, very regular and dipping off like this. So we'll see that. As we walk over here now, we'll see the bedding, overall the disposition of the bedding change quite markedly. It's here, up just over the cave. You see them? We've got a long limb short, long, short, yeah, in that direction. So these folds are verging towards the south.
So it's one slope of the anticline.
Correct.
Yeah.
And you can see as we move from this area over here, we're into an area where they're all now uniformly dipping like this. So now we're heading off towards the core of a large anticline. So this is the hinge zone of the adjacent syncline. Okay, and obviously anticlines and synclines, they share limbs. We're coming out of this incline into this limb, which is the southern limb of the syncline, but it's also the northern limb of the anticline. And that change is, we can see also reflected in the minor folding, which is giving us a clue to that.